Today I'm going to explain why you flip and multiply when you divide by a fraction. There are many ways to explain this. I'm going to give an explanation that students find quite simple. So we'll start with an easy fraction, 6 divided by a half. To understand this, you need to go back to the right level. We always try to do that in the jump lessons. So in this case, it's around grade 3. You have to understand what division means. So look at a simple example, 6 divided by 2. There are many interpretations of this. You could say make two groups and divide 6 up into two groups. But I'm going to start with a size model. So look at a simple example, 6 divided by 2. There are many interpretations of this. You could say make two groups and divide 6 up into two groups. But I'm going to start with a size model. Imagine you've got 6 things. Dividing by 2 might mean put them into groups of size 2. So if you see from the picture, you could divide the 6 things into groups of size 2, putting 2 sticks in each group, and that would give you 3 groups. That's what the answer means. So you could also imagine a chocolate bar with 6 pieces, and then 6 divided by 2 would mean put 2 pieces in each group. That's shown with the circles around the 2 pieces. We could even represent this on a number line. So I've shown that a number line from 0 to 6, and the number line's been divided up into groups of size 2. So it's important that kids understand this. Now that's not the only interpretation of division, but you could also look at division as asking about where the 2, instead of representing the size of the group, would represent the number of groups. But today we're going to stick with size models. When you divide something up, you're cutting it up into parts of a certain size. So this really helps kids understand how to divide by a fraction. You could draw a number line with 6 pieces and tell kids that represents 6 pieces of chocolate. And what would 6 divided by a half mean? A lot of people think the answer is 3. Give me half the chocolate bar. But that's not what it means. The half means, it means give me pieces of size a half. So you could ask your students, if you had 1 piece of chocolate, imagine the part of the number line from 0 to 1. How many halves would fit in there? How many half-size pieces could you break the 1 into? And the picture shows you could fit 2 halves from 0 to 1. You could break 1 piece into 2 halves. If you imagine those are pieces of chocolate, you've broken 1 piece into 2. So now imagine how many of those half-size pieces would you have in the whole chocolate bar? And the next picture shows if you divided the whole chocolate bar up, broke the whole thing up into half-size pieces, you'd have 12 altogether. And that's why 6 divided by a half equals 12. So now imagine 6 divided by a third. Well, how many third-size pieces would fit into 1 piece? You can see that 3 would fit into 1. And so into 6 pieces, you would have 18 altogether. Now I hope you're beginning to see a pattern. The bottom of the fraction, the 3, tells you how many pieces are in 1 piece. You're cutting 1 piece of chocolate up into 3 third-size pieces. So if you look at this long enough, you see that that's why you would multiply the 6 by the 3, because you've got 3 little pieces in each piece, and you've got 6 pieces altogether. So you'd multiply the 2 things to get 18 third-size pieces. So now you could do that with much more complicated or bigger numbers. Imagine 6 divided by 100. It would be hard to even draw this, but you've got 6 pieces of chocolate. Every piece is cut into 100 smaller pieces because you're dividing it into 100th size pieces. And so you'd have 600 pieces altogether. You would multiply the 100 and the 6 to get 600 pieces that would be 100th size. So I hope you can see why when you have 1 on top of the fraction and a number underneath, you flip and multiply by the bottom number. The bottom number is called the denominator. You would end up multiplying the whole number 6 by the number of pieces in the denominator. So now what if the number on top of the fraction, which is called the numerator, isn't 1? So here the number on top is a 2. I tell students, ignore the number on top and just think of it as a 1, and first cut the chocolate bar into third-size pieces. So just do what you did previously. Take your chocolate bar and cut it all up into thirds. And you'll see there's 18 pieces there. Now, 2/3 of a piece of chocolate is bigger than a third. In fact, to make 2/3, you would first cut a piece into thirds, and then you'd have to glue pieces back together. You'd have to take your thirds and glue them back together. So I asked students to imagine if they had a third size piece, a third size piece, and a third size piece. Here you've taken a piece of chocolate and cut it up into smaller pieces, into thirds. How could you make a 2/3 size piece? And students see that it doesn't really matter which two pieces you take. You could take any of those and you would just glue them back together. So you would glue them back together and make a 2/3 size piece. So that's what you have to do with the chocolate bar when you're doing the division. You've cut the chocolate bar into third size pieces, but now you need to glue the thirds back into 2/3. So I've circled a pair of third size pieces to show those glue back together. Now imagine doing that for the whole chocolate bar. How many of those would you have when you glue them back together? So now if you take the thirds and group them back into pieces of size 2/3, if you take all your third size pieces in the chocolate bar and stick them into 2/3 size pieces, the picture shows that you would have 9 of those. I've circled the groups of thirds, put them back into 2/3. You'll see there's 9 of them. And that's what the calculation does. You'll see the calculation, 6 divided by 2/3 equals 6 times 3 divided by 2. Why 6 times 3? That's because you've got 18 thirds in the chocolate bar. Imagine cutting it up into thirds first. That's why you multiply by the 3. It tells you the 18 thirds. And then why do you divide by 2? It's because you're sticking those thirds back into groups of 2. You're grouping them into groups of 2. And so you wouldn't have 18 2/3 size pieces. You have to divide by 2 to find you'd have 9 2/3 size pieces. So that's why you end up dividing by the numerator of the fraction, the 2, because you're putting the pieces back into groups of that size. So now if you look at this long enough and you practice with different fractions, you should be able to visualize what's happening. So imagine 6 divided by 3/4. First you would draw a number line with 6 pieces. Then you would cut the whole thing up into quarters. And how many pieces would that give you? How many quarters would there be in the entire number line? There'd be 24 of them. 4 times 6, because 4 quarters fit into each one. So that's why on the top you're multiplying by 6 times 4. But you don't want quarter-sized pieces, you want 3/4-sized pieces. And those are 3 times as big as a quarter. So that's why you divide by the 3 on the bottom, because you don't have 24 3/4-sized pieces. You've only got 8 of them, because you're sticking them back into groups of 3.